All right, y'all. Do you remember when I showed you how to look at the coordinates of a point in your program? Somebody create a program that says CRPB? No? Oops. Oh my gosh.
Cal?
Who's got a program on here?
I have one. If you go down below where you were, go there I am. All the Gen Lab 3, Gen Lab 4, those are mine.
Okay. So here are your points, and right now it is at 0.1 and at 0.7. What I wanted to do, I guess I need to go. You can adjust all these parts, right? If you wanted to change the speed from one point to the next, how it approaches that point and leaves that point. You can also go to, I think it's the number, and then hit F5. It says position, and here are your coordinates. So on the x-axis, it is minus 328.46. Assuming that's going to be millimeters. Yes, it even says millimeters. So that would be away from the x origin of wherever x is 0, and then from y, wherever y is 0. Remember we went over the Cartesian coordinate deal? So y'all understand what that means, right? Now frames, today we're going to talk about user frames. All we're doing with user frames is adjusting where that 0, 0, 0 point is, okay? And we're going to teach the robot where we want to create that. So, by the way, this W, P, and R, you know what that means or stands for?
World Peace Religion.
Yep, World Peace Religion. It actually stands for yaw, pitch, and roll. And I don't know much about like aviation, but there's with airplanes, they have pitch, roll, and yaw, and aft, and all that shit. Yaw, pitch, and roll refers to the bottom 3 sets of joints. So when X is, you see how the first 3 are, if you were in world, it would be X, Y, and Z axes. And then X, Y, and Z down here refers to yaw, pitch, and roll. And those are the rotation axes. So just to show you, oops.
Sorry, yaw, pitch, and roll? Yaw? Yaw. With the W.
Teach pin of disabled. Oh. So I'm just going to move. This is yaw.
Why is the yaw a W?
Because there's already a Y. So this uses W for yaw. YAW. So that, did you see the yaw rotation? So this is yaw. This is pitch. And this is roll. Make sense? All right, so in those coordinates will tell you where the 0 point of the tool, which I'll ask you about that in a second, is relative to the 0, 0, 0 coordinate if yaw, pitch, and roll were all 0. But then it also tells you what those degrees of rotation is. So you should see, when I do yaw again, you should see that, oh, you won't see it change because this is referring to the point that's in the program, right? They're not changing as I jog it. So anyway, that's line 1, position 1, position detail, and these are all the coordinates. But you see up here at the top, it says point 1 or position 1, I don't know which one it is. And then it says UF and UT, that's user frame 1 and user tool 1. So today we're going to talk about user frames, and then next time we'll talk about tool frames. But being able to change a user frame is really handy because let's say I wanted to use this robot to palletize a bunch of things on a factory floor, right? And we're going to create a program that says, go to this point, get underneath this pallet, pick up the pallet, move something over here and set it down over here. Well, what if we decided we wanted to change the orientation of how things are on the floor? If before I created that program, I created a user frame and said relative to maybe this corner on the table, then you're going to go over to that coordinate, pick up the pallet, go over there, pick up the pallet. And then all those coordinates are relative to there now, not the base of the robot, which is where default in world mode, that's where all those 0, 0, 0 points are, right? Instead, we're going to tell it, well, from over here, I want you to move in this direction 10 inches, lift up 3 inches. Does that make sense? I'm going to teach you how to create that user frame. And this assignment is, let me explain the assignment. You're going to take a laminated sheet, just how it is right there, and you're going to draw your initials, just first and last. So mine would be ZF, right? If you have any roundies, like an S or a Q or something, or U, you're going to have circle points in there, so it's going to take you a little bit longer. Sorry, boss. I really don't care. You got lots of circle points. Okay, you're going to create your initials on that laminated sheet. You're going to make a program that goes down and writes ZF, right? Before you do that, we're going to teach you the user frame. So we're going to say relative to this 0 point, draw your initials in this way and put all those coordinates. All we're doing is create a program. It'll make more sense to you as we go. But if I move that piece of paper then over here, or if I put that piece of paper on the ceiling, if I could do that and it would reach, I could reteach it where that 0 point is, and it would draw your initials in the exact same orientation on the ceiling or over there or over there. Does that make sense? That's what's kind of cool about using user frames. You don't have to reteach the whole program and put new coordinates for your initials up there. You can just say, hey, here's my new 0 point. From there, go do your thing. Cool? All right. So anytime you're jogging or in a program, creating a program, and you want to see what frame you're in, if you hit shift coordinates, remember coordinates is how we go from joint to world and all the other ones. You hit shift coordinates, it'll pull up this little window and it tells me I'm in tool frame 1, jog frame 1, which we're not going to do in here, and user frame 1. Today we're going to do user frame. I'm going to create one. Cool. So in order to get to the frames, you go menu. Setup. Number 6. Down to number 3, frames.
Wait, what was that?
Let me start over. Menu. Number 6 is setup. And then down to number 3, frames. Enter. Now here's your set of frames window, and I can get to user, tool, or jog in this same area once I'm to this point. But right now we're in tool frame, and that's not what I want. So these are all the tool frames. We'll talk about those next week. But I want to go to F3 Other, and then choose user frame number 3. There we go. I'm going to use this first one and create my own user frame on that piece of paper. And then I'm going to make a quick program. I'll probably just do one initial. I'll move the piece of paper, reteach it, run the program, and it should do the same thing over there in a different orientation. Does that make sense? And that's basically what your lab is. All right. So user frame number 1, I'm going to go F2 detail. And here's where we're going to teach it, where the user frame is that we want our new origin point, basically. See how all these are zeroed out? Because that's default. So it's going off of the default 0, 0, 0 position in the middle of the base. But I'm going to teach it 3 points. And with those 3 points, it can triangulate exactly where that 0 point is and where the axes should be from those directions. Does that make sense? If I teach it a 0 point and a plane, you know what a plane is, P-L-A-N-E? Then from that, it can triangulate, okay, well, this is X and Y. This is X direction, this is Y direction. And then Z would be perpendicular to that. Make sense? And I could teach it that at an angle too. I could say this is X, this is Y, and then it would know that Z is in that direction. Cool. The most important thing when you do this is two most important things. Number 1 is you don't want to confuse from the first time that you teach it to the second time you teach it where your X and your Y directions are, because if you do, it'll flip Z. Does that make sense? So in other words, let me see on there, but on this laminated paper, can you see the screen? So this little plus down here is what I'm going to make the 0 point, and then I just have to choose on the arrows. It's a little easier. I just have to choose in these 2 arrows which one I'm going to make X and which one I'm going to make Y. And somebody had already put X and Y on here, but I'm going to redo this on this animation. So it's a good idea to mark which is which before you teach it. 24. So I will make this X, and I'll make this Y. And then all I have to do is teach it those 3 points. So I'm going to teach it this 0, this X, and this Y. So I'm going to teach it those 3 points, and it'll triangulate where those axes are relative to those positions. Cool? Cool. All right. A lot of this also depends on probably a good idea to use something like a pencil when you're creating this. No, it's not. You want to make sure you're using the same. Yeah, because you're going to use a marker to make your initials. So the more definite you can be, the more precise you can be, the more accurate your second deal is going to be. Make sense? All right. So you see where it says orient origin point? That's going to be my first plus. And where it says uninit, I'm going to go down to that one and jog the thing over to that hash mark. I'm going to go through this pretty quickly, but it is worth your time and effort to really get it fine tuned down to the plus sign. But I'm like 5 feet away. I'm just doing the best I can for the demonstration. But I would really try to get it as accurate as you can. And you'll see why when I go to try to do it over there. Anyway, I'm on the plus and I'm going to hit shift. Shift record is F5. It says orient origin point recorded. I'm going to go to X. And in the direction I put the X is the one closest to me. So I'm going to bring it up a little bit. I'm going to go this. I'm going to put it right on the tip of the arrow. Do you think it matters if I put it on the tip of the arrow or if I put it 2 inches back closer to the hash point? Why does that matter? Exactly. I could make it an inch away from that plus mark, but if I'm off by a millimeter that close to it, and I might be off 4 millimeters by the time I get over here. So the further away you can get from that point, the better. But for all of these, we're just going to use the arrows. That's good enough for what we're doing. Make sense? All right, so I'm going to go down a little bit. And I'll make that my X. So I'll hit shift record, and X is recorded. Then I'm going to do Y. It's not super close, but it's close enough. So I'm going to shift record. All right. And when I have all three of those recorded, you'll see these numbers change. What do you think that means? Those are the coordinates relative to that 0 point. But what it's saying is you've taught me, the robot, that this far away from there is going to be my origin. And then the X direction is going to be this way, positive X, right? That's what I've taught it. Whereas in world, the original origin plus X is perpendicular that way. But our X axis is at a little bit of an angle, just how that paper's sitting. But using those 3 points, you can teach it. These are the axes I want you to use, right? Okay, so now I create a program. So select F2, create words. I'm just going to call it program name because I don't care. Enter, edit. So I'm a program made, and then I'm going to create my program. Now this is number 2 most important thing. Number 1 was label your axes. Number 2 is make sure that you're in the user frame that you just created. Because if not, you'll run into what you ran into over there, where you're going to create a bunch of points. And for example, I'm going to shift coordinates. I'm in user frame 1. That's the one that I just taught it. Okay. If I was in user frame 3 and then I tried to do this lab, moved it over there, it wouldn't run because it's saying, hey, you recorded this point in user frame 1 and I'm in user frame 3 and I don't know how to get back and forth. So it's very important that you remember to put your user frame in the program when you're creating your points. Make sense? So I'll just make something real quick. Make a little Z. point, linear. Point, linear. Point, joint. Cool. Erase that real quick. All right, now I'm going to run the program. There's my program. There's my Z. Cool. Now, if I do this right, and since I'm going fast and I'm not being super accurate, it probably won't draw a Z exactly like that. But all we're going to do is move this then over here. You can even do it like in a different orientation and teach those same 3 points in that same user frame. You should redraw that Z in exactly the same place. So I have my program set. I'm in tool frame 1. Now tell me how I get to tool frames to reteach it. That's right. Menu, setup, frames. Now, even though it says used, I'm going to reteach those same 3 points. Does that make sense? So I'm going to jog it. Another thing that you'll want to be careful of is that wherever you move it to, make sure you can get to those 3 points without changing the yaw, pitch, and the roll. Because if you do that, sometimes it will give it a motion error, linear motion error, right? Because it's saying, well, you taught me in this orientation, this origin, to go this many millimeters over here, and now I can't do that because this is rotated. There's ways around that, but just be careful that you can do that. So I'm just moving this a little bit. So I know that I can get to those 2 points without doing crazy.
You'll be here tomorrow for labs, right? Lab day. I mean, not tomorrow, Friday.
Yes.
Me too. Thank you.
All right. So I got it on that origin plus thing. I'm going to go back up to orient origin and go shift record. Go down to X, jog it over to X. shift, record again, new position calculated, and then do the same thing for Y.
I'm trying to keep it on the table so you don't have it tilted Z axis.
I'm sorry?
I'm trying to keep the marker of the same height so you don't have a tilted X and Y. You got a different height.
No, actually you don't, because you mean when I'm jogging it?
Yeah,
Over?
when you're getting the new points.
No, because the first thing is, when I teach it those 3 points, I'm teaching it where that plane is, right?
Yeah.
So wherever that first one was, if that table's different over there and it's kind of like that, it's okay, because I taught it where that plane is. If this over here is like this, it's okay, because I'm going to teach it where that plane is with these 3 points. The other thing is, if you're jogging it from point to point with the felt on the table, there's a chance you're going to run that felt up into the marker, and when you draw it, it won't end up right. But the chances are more than likely when I do this and then I run the program, it's not going to do a great job the first time, and that's typical. But if you reteach the points a couple more times of the new origin, it will get better and better. That's a good question. All right, and there's my Y point. How did I know which was X and which was Y? Because I marked it. Very important. Shift, record, new position calculated. All right, now all these numbers have changed because those are relative to the default zeros. But I basically told it where the new axes are that I want to run the same program off of those coordinates from these new axes that I just taught. Make sense? So if I did it right, we will see it. Go to, so this is user frame 1. Go to select. Program main, is that what I did? I don't remember. Anyway, here goes nothing. Shift forward. Didn't do very good, did it? No. So, and this is what I found over time. If you do that same process again, where you go to user frame 1 and you teach it those 3 points again and again, it will get closer and closer. But it's still kind of, even though it was 3 inches off, pretty cool, right? That you can teach it a program over here, teach a couple points real quick, and then run the same program. You could do the same thing with that piece of paper on the wall. You know what I mean? So anyway, that is that. Any questions on user frames? The most important, what are the 2 most important things?
You keep your X and Y branded.
Label your axes. I'm for sure going to erase those. Label your axes, and then what?
Don't get your roll.
Yeah, that's number 3 probably. Number 2 is when you go to create your program, make sure you're in user frame number whatever that you created. Because if not, you're going to take all this time to make your initials. And you're going to go reteach this point over here. You're going to go to run it, and it's not going to do anything. Or it's going to write something in midair because it doesn't understand the frame that you're in. Make sense? Anything else? Okie dokie. Rest of the time is yours. I don't care what number frame you use. I don't care if you go over. That's the other thing. If you wanted to say, okay, this is Carter's, you could rename this. Detail maybe. Yep. Comment. And you can change the frame number or the frame label. Anyway. Cool.
Is there a reason why the audio is
Because there's no speakers.
So you're gonna be uploading Monday's and today's video.
Yes.